Chemical bonding. Now, elements in the periodic table are divided into 8 groups and 7 periods. Now, members of group 8 or 0 are very stable because of their fully filled outer electronic shells, either a complete duplet or a complete octet. The tendency of other elements to resemble the members of group 8 or 0 is what gave rise to chemical bonding. The various types of chemical bonding include: number 1, electrovalent or ionic bonds. Number 2, ordinary covalent bonds. Number 3, coordinate covalent bond or dative bonds. Number 4, metallic bond. Number 5, hydrogen bond. Number 6, van der Waals forces. Now let's consider example 1. The relatively high boiling point of water and alkanol are due to the presence of the options: A, ionic bonding; B, covalent bonding; C, hydrogen bonding; D, dative bonding. Now, let's consider each of these options. A, ionic bonding. It is not ionic bonding. Ionic bonding only occurs when there is a bond between a metal and a non-metal. So in the structure of water and alkanol, there is no such relationship. B, covalent bonding. It's not covalent bonding, because covalent bonding occurs when two non-metals combine together. C, hydrogen bonding. Yes, it is hydrogen bonding. This is the bond that occurs when hydrogen forms a bridge between two highly electronegative elements. So you can see that hydrogen and oxygen, there is a fairly large differences in their electronegativity. D, dative bonding. It is not dative bonding, because dative bonding occurs when two elements combine and one of them have lone pair of electrons. This is not so in the case of water and alkanol, and consequently the correct option is C, hydrogen bonding. Let's consider example 2. Elements X, Y, and Z belong to groups 1, 5, and 7 respectively. Which of the following is true about the bond types of XZ and YZ3? A, both are electrovalent. B, both are covalent. C, XZ is electrovalent and YZ3 is covalent. D, XZ is covalent and YZ3 is ionic. Let's consider the options one after the other. A, both are electrovalent. Both are not electrovalent because that of XZ is a combination between a metal and a non-metal, which is supposed to be electrovalent. But that of Y and Z is a combination between non-metals, which is supposed to be covalent. So A is wrong. B, both are covalent. Both are not covalent. It is only the bond between Y and Z3 that is covalent. That of X and Z is electrovalent. C, XZ is electrovalent and YZ3 is covalent. That's the correct option, because X and Z is a bond between a metal and a non-metal. That of Y and Z3 is the bond between between two non-metals, and so consequently it is covalent. D, XZ is covalent and YZ3 is ionic. No, XZ is electrovalent because it is a bond between a metal and a non-metal. Y, that of Y and Z is covalent because it is a bond between two non-metals. So the correct option is C. The third illustrative example. How many lone pairs of electrons are found respectively in water and ammonia molecule? The options: A, 2 and 1. B, 1 and 2. C, 2 and 2. D, 1 and 1. Let's consider each of these options. A, 2 and 1. This is the correct option. Now, in the formula of water, of the 6 electrons in the outermost shell, only 2 are used in forming bonds. So the other 4, which makes up 2 pairs of electrons, are not used in forming bonds. While in the case of ammonia, there are 2 electrons, that is a pair of electrons, that is not involved in the process of bond formation. And so A is the correct option. B, 1 and 2. B is wrong. Now in water molecule, we have 2 lone pairs of electrons and not just 1. While in ammonia molecule, we have only 1 lone pair of electrons and not 2. C, 2 and 2 is wrong. It is true that there are 2 lone pairs of electrons in water, but there's only 1 lone pair of electrons in ammonia. D, 1 and 1, it is wrong. The number of lone pairs of electrons in water is 2, but that of ammonia is 1, so it is not correct. So the correct option is A. Example 4. Which of the following factors will not influence covalent bonding? The options are A, electronegativity, B, electron density, C, ionization energy, D, electron affinity. Let's consider the options one after the other. A, electronegativity. Now, the difference in electronegativity of 2 different elements determine whether the type of bonding will be covalent. So, electronegativity is a factor that influences covalent bonding. B, electron density. No, the density of electrons have nothing to do with the type of bond that operates between elements. C, ionization energy. Yes. When the difference in ionization energy is either very sharp or very close, it influences the type of bond. D, electron affinity. Yes, the covalent bonding is influenced by the differences in the electron affinity of the elements involved. And consequently, the correct option is B. Example 5. The bond type in a diatomic nitrogen gas is A, double covalent bond, B, triple covalent bond, C, single covalent bond, D, triple dative bond. Now, let's consider the options one after the other. A, double covalent bond. No. Now, in the formation of a nitrogen molecule, each of the nitrogen atom have 3 electrons for sharing. So each of them will bring 3 electrons for sharing, and so 3 electrons each cannot result in a double covalent bond. B, triple covalent bond. Yes, each of the 2 nitrogen atoms will contribute and share 3 electrons each, resulting in a triple covalent bond. C, single covalent bond. No, each of the atoms will contribute 3 electrons and not 1. So it can be a single covalent bond. D, triple dative bond. This is completely out of the way because in the 2 nitrogen atoms, each of the atoms will have 3 electrons for sharing. And so D is a wrong option. And consequently, the correct option is B. Example 6. The bond type between copper 2 ion and water molecule is A, electrovalent bond, B, covalent bond, C, dative bond, and D, hydrogen bond. Let's consider the options one after the other. A, electrovalent bond. No. Electrovalent bond is the bond type between a metal and a non-metal. So this is not applicable in this case. B, covalent bond. No. Covalent bond occurs when 2 or more non-metals contribute and share equal number of electrons. C, dative bond. Yes, it is dative bond because the copper 2 ion has space but no electron, while water molecule has 2 lone pairs of electrons, which it will make available for the copper ion to combine with it. That is why C is a correct option. D, hydrogen bond. No, hydrogen bond only occurs when there is a linkage between hydrogen and a highly electronegative element, which is not so in this case. And so the only correct option is C. In the halogen, the strongest van der Waals forces is found in the options: A, iodine, B, chlorine, C, bromine, and D, fluorine. Let's consider the options one after the other. A, iodine. Iodine is the correct option because the molecule of iodine is much larger than any other molecule here. So when there is a drift of electrons from one atom to another, there is a longer distance for that electron to drift. And consequently, the partial positive and negative charge that will result will be stronger. That is why that of iodine is strongest. B, chlorine, no. Although there is van der Waals forces, but because the distance which the drifted electrons will move is not much, it will not be as strong as we have in iodine. C is the same thing. It is true that there is van der Waals forces, but the distance which the electron that will drift towards one atom will move is not as much compared with that of iodine. As for fluorine, the van der Waals force is very, very small because the size of the atom is small. And in the light of that, the only correct option is A.